How can I use CRF encoding with nvenc? This is my current command for resizing videos, 1080p, from 2 GB to 300 MB, but it takes a lot of time. I tried nvenc with my NVIDIA GTX 1070. Output size is always 3 or 5 the original size. nvenc does not use CRF. So how do I use nvenc with ffmpeg to convert/resize a video with high quality and small size? Should I use the clue for encoding?
For CRF-based encodes, pass the following arguments in the snippet below to ffmpeg, assuming you're using an up-to-date build, as at the moment. A fixed CQ value of 19 is the recommended setting as it's visually identical to 0, yet preserves good compression trade-off to file size. See this write-up for more on what CRF does. Note that the CQ scale is logarithmic, meaning that 0 is essentially lossless and 51 would be the absolute worst. Quality can be further improved upon by adding options such as B-frames, limit this to 3, at most, and this requires the H.264 main profile and above. Baseline profiles do not support B-frames. To enable B-frames, pass BF.oint to the video encoder, such that BF column V4 would result in the encoder using 4 B-frames, and this can be dynamically tuned by the encoder by optionally enabling look-ahead, via the private codec option, RC look-ahead column VN, where N ranges between 32 to 40. The key parts here are the CQ column V19, and the RC column VBR arguments, which allow you to tune the encoder with the constant quality mode in VBR rate control while adhering to a CRF value of 19. And now, small notes about nvenc, and tuning it for high quality encodes. nvenc, like any other hardware-based encoder, has several limitations, and in particular with HEF, here are the known limitations. On Pascal. For HEF encodes, the following limitations apply. To sizes above 32 are not supported. B-frames and HEF are also not supported. The texture formats supported by the nvenc encoder limit the color spaces that the encoder can work with. For now, we have support for 4:2:0, 8-bit, and 4:4:4, for 10-bit. Extraneous formats such as 4:2:2 10-bit are not supported. This will affect some workflows where such color spaces are required. Look-ahead control is also limited to 32 frames. You may want to look at this editorial for more details. Turing has all the enhancements available to Pascal, with the addition of B-frame support for HEF and the ability to use B-frames as a reference. See this answer for an example on this capability. And on Maxwell Gen 2, GM200X series PIS. HEF encoding lacks the following features. Sample adaptive offset, SAO, loop filter capabilities. Adaptive quantization. Look-ahead rate control. The impact here for Maxwell is that motion-heavy scenes with HEF under constrained bitrates may suffer from artifacting, blockiness, due to the missing look-ahead functions and adaptive sample offset, SAO, loop filtering capabilities. Pascal and Turing has somewhat improved on this capability, but depending on the version of the SDK that the video encoder was built with, not all features may be available. For instance, weighted prediction mode for H.264 encodes on Pascal requires nvenc SDK 8.0x and above, and this encode mode will also disable B-frame support. Likewise, the combination of hardware-based scalars running off the NVIDIA Performance Primitives, NPP, with nvenc may introduce performance improvements with video scaling applications at the cost of scaling artifacting, particularly with upscaled content. The same also impacts the video encode pipeline as NPP's scaling functions run off the CUDA cores on the CU, and as such, the performance impact introduced by the extra load should be analyzed on a case-by-case basis to determine if the performance quality trade-off is acceptable. Keep this in mind, a hardware-based encoder will always offer somewhat lesser customization than an equivalent software-based implementation, and as such, your mileage and acceptable output quality will always differ. With the current nvenc encoder wrapper implementation in ffmpeg, note that valid presets can now be overridden with a tunable, depending on the target workload. See this answer on how this is implemented, as shown in the example given above. And for your reference, with ffmpeg, you can always refer to an encoder's settings for customization by. So, for nvenc-based encoders, you can run You can also see all the nvenc-based encoders and NPP-based scalars, if built as such, by running sample output on my testbed.
For CRF replacement from LIX264 may be CQ or QP from H264_nvenc. CRF select the quality for constant quality mode. CQ set target quality level, 0 to 51, 0 means automatic, for constant quality mode in VBR rate control. QP constant quantization parameter rate control method, from -1 to 51, default -1. Fastest hardware accelerated encode method. Resize resolution on input. In hardware, no need for ffmpeg to be compiled with enable lib for scale_NPP filter. For more info, ffmpeg h encoder equals H264_nvenc.
I'm not an authority on this, but I have done a good amount of research, specifically for getting Blu-ray rips archived with indistinguishable and transparent compression compared to the original rip for files with H.265 video streams using NVIDIA hardware encoder acceleration. I take care when I do this, so before committing to any particular setting, I recommend to test two particular parts of each movie. The two parts I choose are the darkest part of the movie and a fast motion part. I pass through the audio on both tests and only render about 1 minute for a couple reasons. The look ahead needs a prescribed number of frames, and the bitrate fluctuates from scene to scene. Here is what I use with ffmpeg to test out 1 minute of the video from 30 minutes 00 seconds to 31 minutes 00 seconds. Furthermore, I test the file with a QP of 22, 23, 24 for H.265. I can't tell the difference going any lower. Going higher than 24 does start to get color banding on dark scenes or on scenes with a glowing light or a sky with the smooth gradients from white to blue. The map 0, respectively, demuxes the first video, audio, and subtitle streams. Although subtitle is not technically a stream, I just call it that for the sake of simplicity, and assigns them to the first stream in the remuxed file. The rest of the settings are explained earlier on this page or can be looked up. Take note. The container must be MKV to remux in the subtitles. For whatever reason, I just couldn't get MP4 to work. Again, I'm no pro at this, but the results I've gotten from this are exceptionally good. After I check the 1-minute test files and like what I see, I then go ahead and process the movies without the SS00 column 30 column 01 to 00 column 31 column 01. I suggest that when you look at the file, to play back the 1 minute's renders frame by frame.
I believe I found a solution. It seems that H264_nvenc uses QP instead of CRF. This option only works while RC is set to constant.